This is netstack.fm, your weekly podcast about networking, Rust, and everything in between. You are listening to episode 28, recorded on the 20th of February 2026. In this episode, we speak with Théodore Prévot, creator of socketioxide, a Rust library for real-time systems. WebSockets give you a two-way connection, but real-time systems need more: reconnection, heartbeats, and scaling. We explore how these pieces fit together in Rust. Let's begin.
Welcome for another week of netstack.fm. Today we will learn all about the Rust crate socketioxide. We have the perfect guest. It is the creator and maintainer of the crate. So welcome, Théodore.
Thank you. Nice to meet you.
Yeah, so welcome very much. And you are live talking to us from Paris. It's not too far from where we are based. And I'm very happy that you could make it. So as tradition goes, we would first like to get to know you a bit better. Could you tell a bit where you come from, like how you came to get into computers, networking, etc.?
So I started having some interest into computers in high school, even before, but it was more about tweaking computers and disassembling them and cannibalizing computers. Later, I got more into programming, and I discovered the whole world when doing that, and I was really pleased by the all the possibilities that you could have while programming. So I started doing trying to do really hard things, like I wanted to do viruses in C++, and later I got more into web development, web programming. I made some applications, web applications, and also Android applications. And I was quite, it was really nice and comfortable and cool to see the results of what I built directly being used by people, even if it was a limited number of persons. And I decided to continue in this path. In the meantime, I went to an engineering school in Paris, and I met really inspiring people over there. And thanks to them, I continued even more in this path. And so, how did I? From there, how did I went into Rust programming? It was in 2021, I think. I read a study about what were the most ecologic and economic languages. It was, I don't remember the source of the study, but the result was that the top languages were C, obviously, and C++ and Rust, and some others. And I was really intrigued because I had never seen any mention of Rust before. I didn't know the language. And the only thing I remember, it was that was C and C++ were really hard languages that I had that I couldn't master, especially when I started to do programming in high school. So I digged a bit and found all the benefits that everyone said about Rust: memory safety, performances, the fact that the type system is really strict, so it forces you to make correct programs and to enforce a lot of invariants at compile time, extra. And so at that time, I was developing an application for a friend who is a writer, and it was a bit like Notion, but more towards writing and experimenting new ideas about writing. And it was completely synchronized, a bit like the Google Doc with the backend. And the goal was to support multi-editing. It was in full TypeScript, Angular for the front end, and Nest.js for the back end. And I told myself that it would be really interesting to migrate the backend to Rust in order to learn Rust, because I was really, really interested by this language. And that's how I started to work in Rust. And I discovered quite fast that Socket.io was not available in Rust, at least for the server implementation. There is a client implementation that exists and that was existing at the moment I worked on this. So my whole application was using Socket.io through the official Node.js library. And I told myself that maybe I could try to write a Socket.io implementation in Rust for the server side. But I started for the challenge, because I wanted to learn Rust and learn new things, and also I wanted to go towards system programming. I started this project. I didn't expect much. I even didn't doubt about finishing it and having a working implementation one day. And I worked really hard. I learned a lot of things thanks to this project in Rust. Some maybe 6 months later, after the beginning of the project, I started to have a really basic implementation of engine.io. It is the underlying library that socket.io is built upon. And at that time, some contributor came and were really interested by the project. So it really motivated me a lot to keep working on it. And for the 2 last years of my engineering school, I spent a lot of time building socket.io. And I think the best way to learn how to do this kind of libraries is to go check the source code of other libraries. I mean, I read the entire Tokio library, for example, or Axiom or Hyper, and it showed me how to implement certain patterns, how to do idiomatic Rust, and thanks to that, I could implement them in socket.io, socketioxide, and learn things at the same time.
Yeah, I couldn't agree more. I mean, it tests your knowledge of it, and any gap you have will quite quickly be clear. You also have to really think through the problem space as you need to implement it and as you're implementing it, I imagine you will continually learn and improve what you thought you knew and get to know it better.
Yeah, exactly. And it happened several times that I had to refactor the entire code base because I just discovered a new pattern that was more fitted for the use cases I had. I think that one of the best benefits of Rust is that because of the type system, refactoring is not. I was less afraid to refactor than with other languages.
Yeah, agreed. I mean, it's one of those hidden benefits of Rust, and which I think is biggest superpower. Right, you can endlessly refactor, and so you said that you initially were using Socket.io for this application you're writing for your writer friend, and then you decided to port the server side to Rust. In the end, did you actually finish the writer application?
That's that's a good question. No, I didn't. I didn't finish it, and so it is still in TypeScript, and I never touch it, and I don't think I would have the time to migrate it in Rust. But
Yeah, I, I can
quite funny.
understand. Yeah. I mean, it's almost a cliche. Like we often get into these projects, and then for that project, we want to build our tooling or we want to build our underlying library, and in the end, we are just building the library or the framework or the engine, and we don't get to finish the project. But we have more fun than we ever imagined, and what we produce might even create more value than the original application might ever give. So, yeah, like I imagine that, for example, socketioxide is now powering like a lot of applications, which is like almost like a multiplier of what you could have done, I guess, with your own application.
Exactly. That's the thing that is really stimulating me and that pushed me to continue working on socketioxide is going on GitHub and checking the dependent tab and going to check all the dependent projects that rely on socketioxide. I love checking what they are doing, at least for the open source public repository, and I love the feeling of borrowing so many projects.
Yeah, I can imagine. And so I wonder how many people know even about Socket.io. And apparently Socket.io is driven by Engine.io, and as far as I know, Engine.io is by default on top of WebSocket, but it can also fall back to regular HTTP polling, and I guess the client will then just send regular HTTP requests. Like, can we maybe start and unpack a bit what is Engine.io, and is that the lowest layer of Socket.io?
Yeah, it's basically that. Engine.io is almost only usable through Socket.io. I mean, people can use it independently, but there is not much to build only with Engine.io. And so the whole project, Socket.io, started when WebSocket support for web browser was not really standardized, and people still wanted to do server-side communication, broadcasting, and real-time communication with different web pages and different users. And so I don't remember his name, but uh, the creator of Socket.io decided to build this, and it became a standard, especially in the JavaScript community. A lot of JavaScript developer know Socket.io, but it's really it's kind of a high-level thing that uh, that that have uh, changed a lot from the beginning of the project, where the goal was only to support every browser. It was kind of a polyfill for WebSocket to the current state of Socket.io now, where there are a lot of things built upon, like multi-node state communication, namespacing, middlewares, broadcasting, etc., etc.
The authors of Socket.io, they also acknowledge that, okay, WebSocket themselves, they're pretty cool as they are. Like, they allow you to send dynamically messages bidirectionally, but they also mention, okay, if you want to develop like a real-time application, then you do need some layers on top. The HTTP long polling as a fallback is one thing, but they also mention automatic reconnection, also acknowledgement of messages, maybe broadcast if you have like multiple connected clients, scaling to multiple servers, and then connection recovery. That seems to be the things that they mention have needing to add on top of WebSocket if you want to make production scale applications with WebSockets. Does that sound
Yeah.
about right to you?
Yeah, completely. But I would say that currently the protocol suffer a bit from its past, and that things are made to be compatible with long polling and WebSockets. And I think we could have a much better protocol that would allow for faster implementations if it was only relying upon WebSockets.
Yes, I imagine that. I mean, do you have users that still have this fallback to HTTP long polling? Is it still even being used as far as you know?
I don't really know. I may have seen one issue on my project related to long polling, but when I check dependent repository, they always I mean, they don't care about the fallback, and most of the time it will always be WebSockets.
Okay. And yeah, I was a bit surprised to read the automatic reconnection. I mean, I'm not surprised in that, like, I know that the client is not reconnecting, like, let's say you're using it from the web API. But if we compare it, for example, to the server side client, no, actually, now I'm confused with data store. I'm not sure if the server side event client is also reconnecting or not, because I only now recall that data store, which is like a front end library, they
Mhm,
implement server side events on the client side themselves because they were not happy with the server side event client that's in the web API.
mhm.
And I know the one of data store does do reconnection, but now I'm not sure if the default client does it or not.
I'm not sure, but it would be surprising that it does automatic reconnection because, as far as I know, it's just a form of uh, like long-lived connection. Uh, so it would have to, if it's client-side, it would have to handle the reconnection and make initialize new uh, server-side connections. And I think that's something that is built only in the browser. So
Yeah, I know. So that must be something data store specific. And then if we look at the acknowledgements, do I just see that as simple as, okay, there is just a standard format of something that is sending a, I guess, text message is it by the way, do they use the text frames or do they use the binary frames of WebSocket?
So there are multiple parsers. The most common is text. It's a mix of JSON and custom format. And there is also a message pack parser that is fully binary. There are also some others, but they are rarely used and they are not supported with socketioxide.
Okay, but I imagine given the web world, I would think that the text-based one is the most common one, than the custom
Exactly.
format with JSON. Yeah, and so why is the custom format needed on top of JSON?
I don't know because that's more part of the protocol. What I can guess, it's because like that we can route the JSON message specified by the user before decoding it, because the data, the discriminant to route the payloads through the appropriate user-defined handler is defined before the JSON payload.
Okay. And the broadcasting, do I just see that as it's just the server has some way to manage or group clients, and it's just resending messages from one client to all the other clients, or is there something more clever going on there?
It is exactly that, but there is some possibilities to scope broadcasting. There is a notion of room, and sockets can join rooms, and you can broadcast to only specific set of rooms and exclude other rooms. Like you can have a whole bunch of operators to filter and broadcast to only a specific subset of sockets.
And given that they call it rooms instead of something like a channel, is that because initially the typical use case was like a chat server, or because it's
I think so, yeah.
yeah, okay. And then it can also scale up to multiple instances of a server. Like how does that work? Like what does that even mean?
So it is done through adapters because of the rooms, and there is a state on the server side. So if you have a state on the server side, it becomes quite hard to horizontally scale your application because you need to share the state. And this is done through adapters and through another system. Like there is a Redis adapter that is the most common, and there is also MongoDB, Postgre, and Kafka, and other system. As long as the system supports some kind of pub sub channel or stream based communication, the different server nodes can emit data through the adapters to other servers.
Okay. So I suppose there is some kind of high level protocol and you can implement it for whatever database backend you want.
Actually, the protocols are different each time they are different for each adapters. They are custom. And also I make the choice to implement to make my own data formats rather than re-implementing the official protocol because for multiple reasons. First, because the protocol were actually they were not specified nowhere except from in the code, so I had to reverse engineer the whole implementations in Node.js. That was the first reason. And the other reason is that with some other formats, I could improve the performance by a lot. The only drawback that I see is that you can't mix Socketio servers in Node.js with Socketio server in Rust. Whereas if I had supported this the same protocol, it would have been possible. But I think the use case is quite rare, seldom.
Okay. Yeah. And of course, once we have this for horizontal scaling, it's also not hard to imagine how you're gonna do connection recovery, because that's basically the similar scenario as starting a new server, I suppose.
So, alors, there is two kind of connection recovery. So there is recovery from the client side. In this case, in a case of multi-node application, when the client is disconnecting, the server is going to store the state of the socket through the adapter, and like that, when the socket will reconnect, any other server can resume the socket state and the client state. So this is the first thing, and so yeah, also because of the multi-node application, every node is fault tolerant, so you can have a server that's fall down and reconnects, and it will still work.
Okay, very cool. And so all of that is socket.io, but we also know by now that socket.io is actually like in two layers. You have socket.io itself and you have engine.io.
Mhm.
I want to try to figure out a bit where is the boundary. So what those, because in one layer we have the lowest layer is, let's say, WebSocket, and for now maybe we can make WebSocket or like HTTP polling, but I mean basically it's HTTP or WebSocket. That's the lowest layer, but that's below this project. So on top of that is Engine.io. What does Engine.io add on top of that?
So the only other thing that is in Engine.io is a kind of socket representation that is an abstraction over the actual transport. So as you said, WebSocket or long polling, and that's all.
And does that mean that given the world didn't stand still, new protocols get invented, and so we got Quick, and on top of Quick is web transport? Does that mean that Engine.io can use that same abstraction also for something like web transport?
Exactly. Yes, there is work on the official JavaScript implementation to 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 support web transport. It was also a request on my own projects, but I want to wait for Hyper to support HTTP 3, and
Okay.
later to implement this through the correct abstraction, because currently there are some implementation in Rust, but they do not integrate with the HTTP ecosystem, and I don't want to break this whole API compatibility.
You mean the entire HTTP crate and its types? Is that
Mhm.
something that is like, regardless of the web framework that you support, you expect that they use the HTTP crate and those kind of family of crates?
So yes, socketioxide can be integrated with any web framework as long as it supports Tower and Tower
Okay,
types.
okay, okay, very good. And so, of course, we had several episodes in Netstack.fm where we talked about Hyper and Tower. For example, episode 2, we talked with Sean MacArthur, the developer of Hyper. And we also had, in episode 5, we talked with Cora Lerche from Tokio, where we also mentioned a bit about the history of Tower. And then we also had Lucio Franco from gRPC in episode 9, where we, of course, talked about Tonic, and where also Tower and Hyper, etc., was being discussed. So I would refer our listeners to those episodes if they want to learn more about Hyper and Tower. Now, a question about socket.io oxide or socket.io oxides. Given the fact that Engine.io is an abstraction, does that mean that it is something like a trait in your framework or your library, and you could also implement it like on top of any kind of transport protocol, let's say just pure TCP sockets, or is it not as simple as that?
So the abstraction is not done through traits, it is done through Tokio channels. The main reason why is that especially for long polling, there is a need for a kind of channel communication. And so there is not really this need for WebSocket because the WebSocket client server, the WebSocket server that I use, Tokio Tungstenite, or Tokio Tungstenite, I don't know how to say. And so they themselves have an internal channel. But yeah, so the abstraction is done through a Tokio channel.
Okay. But that would be then a Tokio channel over a Tokio channel because Engine IO is an abstraction on top of WebSocket or HTTP polling, right? So does it mean that you are piping channels or how it works?
Basically, yes. I explored this piping thing a bit, and at the end, because I needed a lot of control over the channel, I had to make to spawn a task to pipe the data between one receiver to one emitter, so I couldn't pipe them directly.
Okay. And so given, okay, we have now Engine IO, then on top of that is Socket IO, and as far as I understand, that one adds then things like your namespacing, your data format, your acknowledgements, I guess some kind of metadata messages, and that kind of things. Is that what Socket.io is adding on top of Engine.io?
Yes, exactly. Just to add something, I forgot to say that Engine.io also supports heartbeat, and this is through that the server can detect if a socket is if a client is offline, especially with long polling, because you don't know uh, when was the last time that the client was connected.
Okay, and something like WebSocket has ping pong messages. Is that just what it's using for that, or?
No, it's actually there's actually the heartbeat over a WebSocket.
Okay, so so
It
just
is.
like a regular message basically, but then
Mhm.
within your exchange protocol.
It is an example of why I was saying that the current protocol because it was built originally for long polling. Now it suffer a bit from this past, and it could be complete. It could be more optimized.
Okay, fair enough. But then again, I guess it does make sense that you want to do it on top because you might not. I mean, yeah. I mean, I think for most WebSocket libraries out there, you anyway, I don't think you can have access to the ping pong thing. So I guess you would anyway have to add something on top.
And to answer your initial question about Socket IO, what uh, what do we have in Socket IO? So the basic features are rooms and namespaces. They act both as a kind of namespacing or we could say multiplexing. Thanks to that, a connection can share multiple handlers, and we can add middlewares on top of namespaces to authorize connections or not.
Okay, so that's kind of like a tower layer, which would add something which you do it for a specific namespace or a room. Is a
Exactly.
namespace and a room, by the way, the same, or is it a
No,
layer on top of a layer?
there are two layers. That it makes two layers of multiplexing. So this is the first thing, and after that there is obviously acknowledgement. So basically there is an ID, an ACK ID counter. I don't remember if it's server side or client side, but the client can make a request and wait for an acknowledgement, and the inverse is also possible, the opposite. And it's even possible to broadcast with acknowledgements.
Okay, very cool. Yeah, I can see this encoding, and it's indeed some kind of custom format on top of JSON. I mean, I've seen this in the wild a lot while proxying traffic or needing to intercept or route or modify traffic, and it sometimes boggled my mind, like, what is this weird format? But now I get flashbacks to those times.
And it was one of my biggest challenge, and to be honest, I'm kind of proud of the results, was to deserialize this kind of of data, of custom data formats in a lazy way. So I made a little tech article that you can check on my GitHub blog. It was about building a custom JSON deserializer around the Serde JSON deserializer. And why was it needed? It is because actually to route the packets, even though maybe the initial purpose of this custom format was to be able to route the packet without deserialization, at the end we still have to do some part of deserialization, because the event name that allows to route the packet is encoded at the first value of a JSON array. And the initial implementation was relying of a dynamic deserialization with that JSON value. And it wasn't much performant, because even with really high volume, with a high payload, it would deserialize everything and allocate everything dynamically. That was the first issue. The other issue was that the JSON payload contains placeholders where the client actually sent a binary object, and socketio is replacing the binary object with a kind of placeholder, and it sends the binary object adjacently to the initial JSON payload. And to integrate this dynamically in Rust and integrate this with the type system, it was kind of hard. And at the beginning, it was quite complicated. And the last issue was that in JavaScript, you can emit multiple values, and they would be sent. They would be encoded as arrays. And on the Rust side, so if it would be an issue, because you couldn't differentiate a vector data from a tuple, and there was a need to make this differentiation. So for all of these reasons, I wanted to make this deserializer wrapper. And so the article explains a bit about the different solutions that were possible, and how did I go through the process of resolving those issues through digging and digging and digging through Serde. So now I think I'm a bit more fluent with Serde, but at the beginning it was really hard. I think the Serde bar is really hard when you want to implement deserializer yourselves.
Yeah, I mean, it's definitely something you have to read through. I mean, by now there are also pretty nice unpacking videos. For example, John has a video on decrusting Serde, I think. and I think they even put it on the official documentation, but I imagine that is from after you had to implement yourself. I don't think you had those resources available to you.
Maybe yes, but the main issue I had is because there's a lot of documentation about how to implement your deserializer, given that you made a parser yourself. But there is nothing that show you how to make a deserializer wrapper. And I had a hard time to find a similar implementation. I think I found some things like to track positions while deserializing through the entire deserialization tree, but it was the only crate that I found that implemented these kind of patterns.
Okay. And so another thing that is noticeable when I go through the socket.io documentation is that there were several major versions. You had like the initial version, then you had V1, V2, V3, V4, which I think is the current version. Like, how do you deal with this socket.io versioning from a socket.ioxide crate?
The protocol versioning is there are multiple protocol versions. There is I don't remember if it's V5 or V4, but I only support the current socket.io protocol is V5, and there is a previous one on V4. The changes are quite small between them, and so the previous protocol version can be enabled with a feature flag, and in this case, it will allow you to accept previous protocol client with the little configuration.
Okay, that's good to know. And yeah, I don't really see the. I saw at some point this V4, V5, but then I'm confused with what is the difference then with the version that you see also on the website itself, like this V4X, V4 3X, V4 2X. Is that like yet another version of something else?
It's kind of hard because there are three things. There is the socket.io protocol version. There is the socket.io JavaScript implementation version. There is the engine.io protocol version and the engine.io official implementation version. So what interests us is only the protocol versions, and the socket.io protocol versions are V5 and V4, and the V5 is based on engine.io V4, and the V4 is based on engine.io V3. I didn't find much people who used the oldest version.
It's good to know. And then, yeah, I wonder a bit like where do you put your abstraction? Because I mean, in one, okay, you have the engine IO abstraction, you have the socket.io abstraction, but to me, you could almost certainly see them like separate from your underlying HTTP or WebSocket uh, yeah, library or implementation, because in a way they shouldn't really matter. But as far as I know, you are quite strongly bound to your WebSocket library and your HTTP ecosystem, etc. Was there like a what would be the reasons behind that? Was it just because that's what was easiest at the time, or was there also like a reason why you couldn't make that more decoupled?
So initially it was because that was much easier, and that I was mostly focused about building something working. And later I think about it. Uh, so there are multiple kind of dependencies that well, it would be nice to have a better abstraction. The first thing is the async runtime. Currently, it uses Tokio, and so it would be possible to support something else, but as there is also strong dependencies on HTTP, Tower, etc. This is a whole ecosystem that is tightly bound to Tokio, so I would need to migrate to have an abstraction for the whole dependencies. This is the first reason. Another one is that I don't think there is much usage. The burden of maintaining all those abstraction would be compensated by the number of users. I think no one except no one asks me for abstractions on the dependencies, except from you for the integration with Rama. But this is a whole kind of new complexity, because building a library that is fully asynchronous and making it synchronous is kind of hard. There is a lot of interesting patterns to explore, especially around Sans.io. I don't know if you heard about this.
Yes, we had an episode with it from with Martin Algestem. He's the developer and maintainer of Strom. So he also has UREC, which is like an HTTP client, I think. And so we had an entire episode about the sign IO pattern, and yeah, I like it a lot for sure. It helps a lot in this kind of frameworks or libraries.
And so I got a little challenge that was to try to implement engine.io in C with the Sans.io pattern, but it's I mean, it's a whole new complexity compared to Rust, especially because I need some type of custom async runtime to be able to make Heartbeat working.
Yeah, I mean, doing it also merely in C is definitely like a bit different than doing it in Rust. And yeah, I mean, but it does help a lot because like you can just test it decoupled from your actual IO layer, because that's what Son IO is about. It's about making sure, okay, you focus on your protocol, and for example, you make use of Tungsten, and as far as I know, they also implement in a Son IO way where they don't really care so much about the underlying IO protocol. It's more you just have something that implements the protocol. So in that case, WebSockets, and then underneath it, you have something that provides you with a byte stream, but you don't really care so much where that comes from. It could be just an in-memory byte stream. It could be a TCP. It could be whatever, like as long as it works. And then of course, on top of that, you would have like the HTTP handshake, but that's kind of like a separate detail because it doesn't really matter, and that also happens before WebSocket. It also happens before Socket IO, I imagine. Or do you do something special with HTTP handshake? Do you, for example, have custom headers in Socket IO?
No, there is no custom headers. There are parameters extracted from the query params, but nothing more. Relying on statically on this dependency lower the complexity bar by a lot, and there are a lot of things that I want to work on, and higher level things that I think that are really wanted by the community, and so I think it's more a priority compared to abstraction. Also, I would add that the user base of socketioxide is more. There is a lot of Rust newcomers, exactly like myself when I started Socket.io. The main reason why is that people know Socket.io, they have implemented it, and they have used it, in JavaScript, and they come to Rust, and the first thing that they say to them is, "Oh, I'm going to migrate my implementation, my server, my application in Rust." So they fall on my lib, and they kind of start working on doing the implementation with socketioxide, and that's how they mostly get into Rust. And it is really, really high level compared to other protocols. It's not that performant, and so there are a lot of things like the need for integration testing, adapters, ease of use documentation that are much more important than actual abstractions on the network dependencies.
Yeah, I fully agree, and I understand your point of view. But then I also see, as you mentioned yourself, you wanted a server implementation. Before that, there was already this Rust Socket IO client implementation, and it's still there. But yeah, I mean, it seems to be a bit of a dead project. I mean, maybe it's just finished, which is also fine. But yeah, there seems to be like a lot of overlap, because I imagine that the underlying protocol is pretty much the same between the client and the server. You have, of course, some features which are server side only, like broadcasting, but
There,
there is a lot of overlap, no?
of course, yes, there is an overlap. Uh, uh, Initially, I was wondering if I could try to integrate it or make a common implementation under the Rust Socket.io project. At the end, I didn't do it. I did something on my side. Uh, but there are a lot of different, even if we, without talking about the client versus server, more about the API philosophy and the ease of use, etc. There are a lot of different things. And so that's the reason that I didn't want it to merge or try to merge the two projects. And for example, the way we specify handlers in Socket.io is completely in socketioxide is completely similar to Axum. So people that use Axum are really comfortable, and also it avoids a lot of manual boilerplate like boxing closures and boxing features. Also, it implements the extractor patterns, so there is never unused parameters, and people can build their own extractors to do custom behavior. So, as you said, the Socket.io client is currently a bit unmaintained. I don't really know how much the creator invests his time. And so I was thinking about making a client implementation on with socketioxide. And the main reason is not really to like for concurrency reason. I don't think there's the need for we don't need to fight each other, especially in the open source world. It's more because a lot of people ask me for testing and end-to-end testing. The best way to support integration testing would be to to have client socketioxide that share the same base type through a core library. And thanks to that, the people could make their test, and this would go through the whole tower abstraction without needed networking. When you test, when you're doing making integration test with Axum, you are sending HTTP requests often through Tower, because an Axum router implements Tower service, so you can just call one shots and make handcraft an HTTP request, and because there is the same base types, the integration testing is really easy, and I would like to have the same experience with socketioxide.
Yeah, I understand. So how do you currently do your integration test? Do you actually just open transport layers and work with the Rust socket IO client implementation, or?
So um, inside the library, I'm doing there are a lot of different type of testing. Integration tests are made by manually crafting the message types and accessing some internal implementation. So for the project needs, it's okay, but it is absolutely not usable and ready for main users. And also there are end-to-end testing. There is a test suite that have been made by the official maintainer of the Socket.io protocol that is testing everything, uh, and that assure that the protocol is respected.
Yeah, given all this, what is kind of the future for socket dioxide besides the client implementation that you might want to do? Like, what's on the roadmap and what are your priorities a bit?
So what's on the roadmap? I would say first support for other kind of adapters. Currently, there is only MongoDB and Redis. I have started Postgre implementation that that I'm working on. There is also, as you said, the client, and I started with kind of high objectives because client implementation should be uh, less complex, and so I wanted to be uh, uh, runtime async, mostly by using only uh, uh, manually defined futures and manually defined streams. I don't know if it will be possible, but it's something that I'm exploring. And if it's too hard or that is not possible, I will fall back on doing a more classic implementation. But I think it's really important to be runtime, async runtime async runtime, to have this async runtime uh, abstraction, because uh, clients might be used in WebAssembly, for example, and in WebAssembly you won't going to include the whole Tokio runtime. So that's first example. You might want to use this client in uh, in embedded systems. It would be a bit weird, but why not? And so because of that, I want to focus on this fully uh, async runtime abstraction.
Yeah, very brave of you. It's definitely, depending how complex your library is, certainly not an easy feat in the current version of Rust, I would say. Like I tried, for example, at the beginning to make Rama runtime agnostic, and yeah, it quite quickly got very painful. I know Hyper did succeed, but it does make things a lot more awkward over there. I feel like you have a lot of abstractions over little simple things, and next to that, I also discovered that Tokio. I discovered over the years that Tokio is a lot more powerful than I gave it credit for. Like you can run it on embedded systems. I think you can, depending on what tier of WebAssembly you want. I think you can use Tokio as well.
Yes, there is a WebAssembly compatibility.
Yeah. So and another reason I wanted it for is, well, okay, what if you want to run a runtime per thread? But even that you can do with Tokio. So yeah, all the reasons I had initially to make this agnosticy possible kind of got like, yeah, I removed the reasons one by one, and in the end I didn't find so much reason anymore to go through all the effort. That said, the scope of Rama is like a lot bigger than socket dioxide, so I think in your case it might be possible, but still I wonder how much request there really is for, because I imagine the typical Axiom user, the most of the, yeah, I guess, yeah, they I don't think they really anyway care about something that's not Tokyo.
No, I think it's also more of a challenge for me that I wanna explore.
Okay, yeah, I mean, I think it's cool anyway. So then another question I have is like, okay, initially you developed this with this interest, and you managed to keep this interest over the years. You also managed to keep working with over the years. Is this something you can do as part of your job, or is it like purely a free time project?
It is purely a free time project, and currently this last month, it it's became quite of hard to take time because I have quite challenging work in Rust also, and because of that, it's hard to find free time. Uh, it's not especially about having the time to code. It's more about having time, having space to allow thinking about the architecture and the organization and how am I going to fulfill this feature to all of all of that is being a bit replaced by my work that is almost as challenging as this implementation of socket dioxide. So yeah, a bit hard for me.
Yeah. Does that does like how do you see that I'm being sustainable? Is it just because it's anyway so interesting to you that you keep finding time to work on it, or how do you keep yourself motivated to keep working on this?
On socket dioxide,
Yes.
uh, it's mostly because the fact to contribute to open source, it's really important for me, and I love the philosophy behind this. Uh, uh, As I said at the beginning of the podcast, it's really important for me, and it brings me a lot of joy and to just go to the dependence tab and see what everyone is building with socketioxide, and uh, it makes me really happy, and it gives me the motivation to continue, even if it's really slowly because I don't have much time.
Good. Well, in that case, I cover everything that I wanted to cover about socket dioxide. I would encourage people to explore the project. It's quite a cool one. That said, I imagine that anybody interested in Socket.io and is also into Rust, they probably already discovered your project, so I don't think they need the extra shout out. But anyway, I think it deserves a spotlight, and I'm very grateful for the work you put into it. Is there anything else that you think we didn't discuss about the project or the underlying projects which you would like to highlight?
No, I think I don't have any other ideas.
That's fair enough. We already discussed about quite a lot. And so I wish you like a pleasant 2026. Like we're already almost end of February. So I guess we are already past the New Year's resolutions. But regardless, I hope it's a year that's good for you and for the project. And I wish you the best of luck with it.
Thank you.
netstack.fm is brought to you by Plavayo, building secure, open, and resilient infrastructure with Rust, protocols, and purpose. This show is also made possible by Rama, the open source networking framework. Plavayo offers service contracts and welcome sponsorships to keep building and supporting its ecosystem. The theme music of this podcast was composed by DJ Mailbox. If you enjoyed this episode, don't forget to subscribe on your favorite podcast platform and leave a 5-star review. It really helps others discover the show. Thanks for tuning in. We'll see you next time for the next handshake.